Welcome to the course Depreciation, Alternative Investment and Profitability Analysis. Today's lecture will start the module 2, that is alternative investment, and in this alternative investment we will take annual cost method. So, in this lecture I will introduce to the alternative investment and annual cost method. Alternative comparison or alternative investment. The common problem confronted in engineering economics are those where alternative comparison between two or more mutually exclusive alternative investments compete, involving different series of capital disbursements. For example, if one alternative have both less capital investment as well as operating cost, there is no need of comparing it with other alternative. However, the comparison becomes essential if one alternative offers higher initial capital investment, but lower annual operating cost in the successive years in comparison to the second alternative, which offers less capital investment initially, but subsequently higher operating cost. In such cases, one has to find trade-off between the future advantages of a lower operating cost vis-a-vis disadvantage of higher initial investment. Where different series of disbursement are compared, it is necessary to reflect the time value of money under each alternative. A variety of methods exist for selecting the superior alternative from a group of alternative proposals. Each method has its own merits and applications. The present module demonstrates how to apply the profitability measures to select the best alternative out of a set of mutually exclusive alternatives properly. Mutually exclusive alternatives means that the selection of one alternative excludes the consideration of any other alternative. Now, in this lectures we will cover annual cost method 1 and 2, present worth method, perpetuity method, rate of return method, incremental rate of return method, minimum return as a cost methods. So, all these methods we will study in this course. Annual cost method, which is the topic of this lecture. In engineering economics, the annual cost method or equivalent annual cost or annual worth method is the cost per year of owning and operating an asset over its entire lifespan. This method is often used as a decision making tool in capital budgeting when comparing investment projects of unequal lifespans is required. For example, suppose if project A has an useful life of 11 years and that of project B is 15 years, it would be inappropriate to simply compare the net present value of both projects unless neither project could be repeated. Now, let us see how to derive the formula for annual cost method. Now, in this slide before you it is given, I am explaining this. Basically if I draw a timeline, at timeline t equal to 0, a investment is done, an investment is done here. Now, this is the time when the property retires. So, annual cost method converts this depreciable amount into a series of payments whose when present value is calculated, when all these payments when converted into its present value and add up, then we find that the whatever value I have invested at t equal to 0 equals the summation of all present values. So, annual cost can be calculated with this present cost of asset into rate of interest divided by 1 minus 1 plus rate of interest to the power minus useful service life. So, basically this is a annuity. So, we can use the annuity formula A is equal to P I 1 plus I to the power n divided by 1 plus I to the power n minus 1, and when this is simplified, then we get a formula A is equal to P I 1 minus 1 plus I to the power minus n. This is the formula. Or we can use this also as well for calculation of annuity, which is a annual cost in the present case. Present value and net present value have a serious flaw when it comes to making comparison between available investments. The flaw lies in the fact that you must set that opportunity rate, a fixed rate, to be used over the investment life, and as we noted that opportunity rate must reflect comparable risk for comparable investments. That means, you fix a quantitative calculation based heavily on a qualitative judgment. In comparing two investments, a mistake or inaccuracy in the opportunities cost, that is discounted rate, will lead to a distortion of present values. Now, we take a example. Now, the objective of this example is, given the capital investment, 0 salvage value, attractive rate of return, equal estimated life and different annual operating costs, compare two different investments based on annual cost method. So, in the example number 1, the data for two machines are given. Select the appropriate machine based on annual cost method. So, machine A, machine B. Capital investment, this is 45,000, this is 30,000. The useful life N is 10 years, 10 years. Operating cost is equal to rupees 8,000 per year, and this is rupees 15,000 per year, and I is 10% and 10%. And our aim is to find out using annual cost method at which machine I should select. Now, the annual cost of the capital recovery is the annuity based on time value of money that one has to pay throughout the useful life of the machine, which will be equal to the capital cost of the machine at the start of the first year, that I had already told you. So, annual cost of capital recovery, annual cost of capital recovery is equal to capital investment into I 1 minus 1 plus I to the power minus n. This is the value. So, for A, if I calculate this, then it is equal to, for A, the annual capital recovery is equal to 45,000 into 0.1 divided by 1 minus 1 plus 0.1 minus 10 to the power minus 10, which comes out to be rupees 7323.54. Similarly, for B, if I calculate the annual capital recovery factor, then this is 30,000 into 0.1 divided by 1 minus 0.1 minus 10 is equal to rupees 4882.36, and this is per year and this is per year. So, if I keep this value here, 7323.54 and 4882.36. So, what basically I have done, that I have converted this capital cost, whose lifespan is 10 years, into a per year cost. Now, so annual cost will be basically the addition of this and this. If I add these two, this becomes rupees 5323.54, and if I add this and this, then it becomes rupees 19,882.36. So, what do we find? That machine A is cheaper because its cost is 15,323.54, whereas the cost of the machine B is 19,882.36, and hence our selection will be machine A. So, we will go for machine A. This selection we have made based on annual cost method. Now, this is a table I had given to show that if the present value of all the installments are calculated, comes out to be the original cost of the equipment at t equal time equal to 0, that is for A machine it is 45,000 and for B machine it is 30,000. I have calculated for A machine only. So, it is 45,000. Now, let us take the second problem. The data of two machines A and B are given below. Data for two machines A and B are given below. Plot how the net present worth or for both machines A and B vary with variation in minimum acceptable rate of return from 6% to 30%. Now, here I have again two machines. Now, the capital investment is 10,000 here, 8,000. Now, useful life is 10 here, salvage value is 0 here, operating cost is 3,000 and here 3,500. Now, rate of return is 15%, here 15%. Now, you have to select machine A or machine B based on the annual cost method. So, basically this cost is per year and this cost is for 10 years. So, I have to convert this cost into per year cost using annual cost method, and then I can add this with this to find out the total annual cost, and based on the annual cost I will take a decision. Now, let us see. Now, annual of capital recovery for A is equal to 10,000 into 0.15 the value of I, 1 minus 1 plus 0.15 to the power minus 10. Now, this comes out to be rupees 1992.52, and this unit is per year. So, the total annual cost, that means per annum how much I am spending, is equal to rupees 1992.52 plus this operating cost, which is per year basis 3000. It comes out to be rupees 4992.52. So, this is annual cost of capital recovery is 1992.52, and when I add this with this, this becomes rupees 4992.52. Similarly, capital recovery for machine B will be 8000, and this comes out to be $1594.02. So, this is 1594.02 plus 3500, and this comes out to be rupees 5094.02. So, this is 1594.02, and we add this becomes rupees 5094.02, this plus this. So, as the annual cost of machine A is less than machine B, so my selection will be A based on annual cost method. So, summarizing the lecture, in this lecture I have introduced the concept of alternative investment, and one of the methods for achieving the alternative investment, which was annual cost method, has been introduced, but some part of annual cost method has been introduced in the lecture number 2 of this series, that is module 2. We will see more problems on annual cost method. Thank you.